Let's start. So for chapter 3, this is entitled Sampling from Populations, the Standard Error of the Mean. Again, sampling from populations, the standard error of the mean. For this chapter, we are all expected to distinguish between samples and population, and then describe the way in which sample size and the standard deviation jointly influence random sampling error, and show how the standard error of the mean, or SEM, can be used to indicate the quality of a sampling scheme. So first, let us define some terminologies that is related to the concept. Okay? Now, when you say population class, we use this to refer to all the members of the target that we have in research, or our subject. So meaning, for example, we want to know the IQ level of the BS pharmacy students. So all of the students who are enrolled in BS pharmacy will be members of the population. Okay? Again, lahat ng students na na-enroll sa BS Pharmacy, population ang tawag doon. So all the subjects, all the individual, or even all the objects na included, or nandoon yung criteria, they possess the criteria or the behavior, then masasali sila sa population. Okay? So, kung ang isa-sample naman natin ay ang tawag dyan, lahat ng residents ng General Santos City, so lahat din yon. Kung resident ka ng Gensan, kasali ka sa population. So, doon natin ikakandak ang ating study. Okay? So, ito yung tinatawag natin na population, but in research, we don't really include all the members of the population when we give out our questionnaires, or when we do the experimentation. It will be impractical for us, especially if we have a large population like residents of General Santos City. I don't know what is the current census, but definitely if we think about it, that will be a lot of people. And again, that will be impractical for us to do research to everybody. Therefore, we just get the sample. The sample is representative of the population, meaning we just get a portion from the population and do our research to them. So they will be selected. We can select them randomly though, but other researchers would prefer not to randomly select them, but nevertheless, we just get a portion, a little portion from the population, and then ang tawag natin dyan ay sample. So okay lang sana if our population is just 30 people, and we can do research to that 30 people kasi madali lang yon sila ma-reach out. But if masyado nang malaki, again, magsasample na tayo. So yun na I believe na na discuss ko na ito last time, especially I have discussed the anong tawag dyan? Sampling techniques last time. So ngayon, let's discuss types of sampling error. Okay? So sa types of sampling error, the number one here is the bias or systematic error. So when you say bias or systematic error, we have here a consistent form of misestimation of the mean. Either most samples would overestimate the value or would underestimate it. So again, When you say bias or systematic error, this is a type of sampling error wherein we will, because of the sample na kinuha natin sa population, it's either ma-overestimate yung totoong result or ma-underestimate. So, example here, in experimental observation, systematic errors usually come from the measuring instrument. So example, hindi questionnaire, experimentation talaga. Now, yung ginamit natin, example, nag-measure tayo ng mass, yung weight ng ating sample. Now, however, yung ginamit natin na instrument, yung analytical balance is not calibrated. So hindi siya nagfa-function ng talagang well. Now, ang mangyayari dyan, because of the problem in the instrument, we will not get the correct weight of the objects. And so if we get the mean of all the objects or the average, hindi yun siya talaga ang totoong mean. Kasi nga may problem tayo with our instrument. So that is an example of a systematic error or a bias error. So there is something wrong with the instrument, or if there is something wrong with the handling of our data, pwedeng na mali natin tally lahat. So bias error na yon or systematic error. Mali yung machine na ginamit natin or mali yung instrument na ginamit natin. So that's again under bias or systematic error. We will not get the correct measurement or the correct mean for the population, correct data, because there is something wrong with what we are doing. There is something wrong in our procedure, or there is really something wrong with our instrument. Now, another example, this is not an experimentation, this is a survey. But if we read this, we will really see that there is a bias error or a systematic error. Now, if we read this, if we want to determine average alcohol consumption among the citizens of General Santos City, we might recruit our subjects by giving out questionnaires in a bar in the town center. So again, the goal of the research is to identify how much alcohol is being consumed by the citizens of General Santos City. However, in the procedure, the researcher may go to the bars in the town, and that will actually affect the result of the research. Kasi it will be pretty obvious that if you go to the bar, the people there would most likely consume alcohol, and hindi mo nasali sa sample. Paano naman yung mga citizens na hindi umiinom ng alcohol? So magkakaroon ka ngayon ng conclusion na, oh, the people of General Santos City are consuming a lot of alcohol. So yun yung magiging conclusion mo, which is hindi naman siya dapat ganon, kasi nga hindi mo naayos yung procedure. Nag-concentrate ka lang doon sa people in the bar na most likely iinom talaga ng alcohol, and nakalimutan mong isali sa sampling mo yung mga teetotalers or yung mga hindi talaga umiinom ng alcohol. That will actually balance the mean na supposedly makukuha natin. So again, when you say bias or systematic error, it might be because there is problem with your procedure. Okay, the sampling is not really correct. And when you did the sampling, hindi siya well represented. Hindi siya naging random, and ikaw na mismo yung nag-choose kung sino yung magiging respondents mo, and hindi mo na take into consideration na meron din iba na hindi talaga umiinom ng alcohol, and that will give us the correct na average supposedly. Okay, so yung characteristics of a bias or a sampling error, if we will going to repeat the procedure several times, most likely we will still get the same error in the same direction. So kung sa pag-inom na survey, kung doon ka balik sa bars in the city, you would most likely get the same answer, that the General Santos City residents are consuming a lot of alcohol. Ganun yung magiging conclusion mo when supposedly kung ibabalance natin sana yung sampling natin, hindi naman siya dapat. Okay? So when you do sampling class, if you're going to do your research some other time, we have to make sure that the sample that we are going to get is representative talaga of the population. Okay? So well represented lahat. Hindi lang kung saan yung sa tingin mo convenient for you, doon ka lang kakandak ng research mo. So the problem now lies with flaws sa experimental design or sa procedure mismo. Sa procedure na ginawa, sa sampling, or even kung experimentation ito sa instrument. So kung magkakandak kayo class ng experimental research when you are in your third year na, you have to make sure that all instruments are properly calibrated para maiwasan natin itong sampling error na ito. So definitely the systematic or bias error can be avoided. It can be avoided or it can be minimized by improving our research design, improving our procedure, and really looking into it na we can recognize errors along the way. So, and then we can eliminate them. So our goal actually is really accuracy. Remember, when you say accuracy, it refers to how close the measurement is to the true or the correct value. That is our goal when we do research. So just like the drinking survey, it will not be accurate if you will just go to the bars in the city, kasi again, you will really get a high amount of alcohol consumption there. You have to make sure na kasali din naman yung hindi umiinom, yung mga teetotalers sa city. So that will really give us the accurate value for the mean average consumption of alcohol in the city. So as much as possible, before conducting the research, you have to review everything. Kasi when you review your procedure, you can actually identify errors that you will encounter para ma-avoid yan siya. Yung hindi talaga natin ma-avoid and hindi din natin ma-minimize is yung tinatawag na random errors. Because remember, we are just doing sampling, or we are getting samples only, not really the whole population. If the whole population yan siya, we can really get the correct value for the whole population. Like if you have 1 million residents of General Santos City, you will be sure na, oh, this is for the whole population. However, I told you a while ago that doing research for the whole population is impractical. It will consume a lot of time, it will consume a lot of effort and money on us kung aabutin natin yung 1 million na yan. So, kaya tayo nagsasample or nagsasampling. Kuha lang tayo ng a little portion. Now, since little portion lang yan siya of the population, we will really expect that there will be random error along the way. If you can still remember the formula for this, the Slovin's formula, remember you have there the letter E, which is the allowable room for error. We really expect that in research na there is really error because we are just doing the sampling. So not all the members of the population will be included. However, even if we review our procedure, we calibrate our instruments, this random error is most likely unknown and unpredictable. And we cannot really see that ahead of time. So meron talagang rooms for errors yan. Now, principal characteristics of a random error, most likely there will be an equal chance of over and under estimation. Depende na lang yon sa participants or sa respondents na nakuha natin, or depende na lang yun sa sample na nasali natin in the research. So even if we have the most sophisticated research design, na-review na natin lahat ng procedure, mag-expect pa rin tayo ng random error. And it is impossible for us to get rid of that. And that is the reason why when we present the results of our study, you have to bear in mind that you don't prove anything in research. You may add up to the body of knowledge, but then again, there is not yet anything that you can prove because remember, you have the room for error there and it needs to be further validated para mawala yung errors doon. Kasi nga sampling lang yung ginagawa natin. Now, these are factors controlling the extent of random sampling. So for the sample size, sa statistician's point of view, if you have big samples, it means a good sample. Meaning you can properly represent the population if you have a big sample. However, if you just got a very little portion of the population, meaning you will have a very small sample size, that will be a bad thing for the statistician's point of view because you will have limited answers from them, you will have limited data, and that cannot represent the whole population. So as much as possible, we will be getting big samples from the population. If you have 1 million residents of General Santos City, you really have to get a big portion of that as your sample. So kaya tinitingnan din ito sa research kung how big your sample is. If it's very small, then your conclusion will be limited. It cannot represent the characteristic of the whole population. And then variability within data. Remember, we will have a lot of data. If we do experiment, we just don't do the experiment once. We do a lot of trials or replicates. So therefore, merong mga variations yon, and as much as possible, we control those variations. Okay? So for everybody's point of view, not just with the statistician, if you get a big standard deviation, that means it's actually a bad data. Your data is not precise. But if you have small standard deviation, that means your data is good. They are close with each other, they agree with each other, they are close to the mean. Yan yung ibig sabihin ng small standard deviation. So our goal naman here for the random error is as much as possible, we will have precise data. Okay? Meaning they agree with each other. Even if you do the experiment all over again, you will have a data that is close to the previous ones that you have. Okay, so in doing research class, please take note, we don't do population sampling unless konti lang yung member ng population. We do the sampling. Okay, we do the sampling, so we just take out a portion of the population and sila yung sastudihan natin. But we have to review our procedure first and recognize if there are systematic or bias errors along the way, if we have flaws in our procedure, or if we have something wrong with our instruments, we have to correct that in order for us to avoid or minimize bias errors. Okay, because our goal is accuracy. However, the random error is unpredictable. And even though we are going to check everything, we cannot really identify this. So we always have room for error. And that is the reason why we do trials and replicates to check whether the data that we get are precise. So meaning they agree with each other. Now, we have the so-called standard error of the mean or the SEM. SEM. Standard error of the mean. Minsan, kino-compute ito ng mga statisticians to know whether there will be a sampling error that we can anticipate or wala. Okay? This will actually dictate whether our sampling is good or not. Now, this is how you are going to interpret the result of the computed standard error of the mean. A high SEM will tell us that the sampling that we do is weak and it will be causing a lot of errors. But if we will get a low number for the SEM, that means our data is precise and that the random errors will be small. So since we cannot identify random errors, they are unpredictable, we will just check whether our sampling will give us a lot of errors or not. So this is our formula for SEM, or the standard error of the mean. SD is equal to the square root of the sample size. So we just need the standard deviation here and then divide it sa square root ng sample size. So kung ano nga yung standard deviation kanina sa quiz natin? Kindly send sa chat ano yung standard deviation nun? Okay, 0.92. Sige, kunin na lang natin yung 0.92 and then divided by sample size natin 10, right? Parang 10 ata yung data na yun. So i-divide natin siya sa 10. Okay, tama. So 0.92 divided by square root of 10. That's 3. Excuse me. 162277766. Kunin ko na lang lahat. 0.92 divided by this one. This is 0.29. So 2 decimal places. So this is not SD. This is SEM. Okay. So this is SEM here. This is the standard error of the mean. So we have here 0.29 and it is considered a very small number. That means the sampling done by the researcher for the set of data na binigay is good and it will not be liable for too much random error. So that's the use of the SEM class. Pero minsan lang ito chine-check ng statistician. Especially if you have a lot of samples, pag umabot ng more than 100 yung samples mo, most of the time, the statistician will not compute for the SEM anymore. Kasi remember, a big data, a big sample size would mean you can get rid of those error. You will get more precise na data. Ano yung considered the high? Just like the standard deviation, if you see SEM na umabot na ng 50 pataas, that will be considered a very high SEM na, and it means that the sampling is weak. Ang ginawang sampling, yung pagpili ng mga members ng population na isasali sa research is weak. Hindi well represented yung sample and magkakaroon ng maraming errors along the way. Okay? So this is just a simple computation. You just need the SD and the sample size para makuha natin yung SEM. Ang problema niyan pag mali yung computation ng SD. Okay? So, when you say standard deviation again, class, this measures the variability or dispersion of our data, meaning that measures the precision of our data. And then, kapag malaki masyado yung standard deviation mo na nakuha, kagaya ng SEM, meaning hindi precise. May something wrong talagang nangyari sa research nyo. Na-experience ko ito sa experimental research last, I don't know pa, I think that was 3 years ago, na yung data nila malayo talaga with each other. Parang ata yun? Ano study yun? Weight lowering activity of a certain plant. So pinataba nila yung kanilang rabbit and then they gave the plant material and then they measured the weight of the rabbit if bumaba ba or hindi. However, after the experimentation, they have very varying weight reduction. And then when they computed the standard deviation, it's very big. Umabot ata siya ng 79. And then napansin talaga yun ng ng panelist na ang laki ng standard deviation for their research. There is really dispersion there among individual values of the weight reduction. So, pinaulit sila. Nakagasto dito sila bonggang-bongga. They were asked to repeat the experiment kasi nga may something wrong sa precision ng kanilang data. Pero hindi na yung pinakompute yung standard error of the mean. Sa standard deviation na lang siya tinignan. Most likely, they will really also get a very big value for the standard error of the mean. Yung standard error of the mean kasi is mostly on the true population mean. Whether the data collected is close to the true or the correct value, the true population mean. But you expect class that the SEM is always smaller than the standard deviation kasi you will use the standard deviation in the computation. I-divide mo pa siya sa sample size. So talagang liliit yung kanyang value compared to the standard deviation. However, both of them are used to know whether our data is precise or not, or even accurate for the SEM. So yun actually yung chapter 3, very short for the chapter 3. Any question or clarification? Wala question? Wala. If mag-quiz tayo, wait lang, unahin ko yung may times din po. No, I think walang times, there will be no time na mas malaki yung SEM kaysa sa SD kasi you will use the SD via in the computation of the SEM, and then i-divide mo pa siya sa sample size. Most likely mas maliit talaga yung value niya. Pero magkaiba sila ng nire-represent ha. Si standard deviation, yun yung sa precision of the gathered data, whether they are close with each other. Si SEM, ang target niya talaga is to know whether the collected data is close to the true value of the population. Meron. Pero I will give you the data. You have to compute for the standard deviation first. And then you have to identify syempre the sample size. And then you can always get the SEM. Pero madali lang naman yung interpretation niya pag malaki or maliit yung data. Pag malaki, syempre hindi precise yung data mo or hindi siya magre-represent ng population. And then pag maliit, yun yung gusto natin. Dapat maliit yung value ng computed SEM and standard deviation. I just have to give you a background of the standard error of the mean, but I seldom again encounter this in research. The statisticians would most likely not compute for it, and most of the panelists will not really look for the SEM. They will look for the standard deviation. So yung standard deviation talaga yung pinagtutuunan ng pansin sa research. Okay, anything else? Wala na.